Well, today I've decided to transition over to a 24 volt system because it's going to offer me quite a few advantages. Because just now this charger can only take a maximum input of 40 amps. Now at 12 volts at 40 amps that's roughly 400 watts. So at 24 volts I should be able to charge my bike batteries at 800 watts. So halving my charging time. Also, what I'll do before I do the conversion is connect all the 6 volt batteries in parallel and do a big equalisation just to even them up, because I did buy them at different times, so I don't know if that's going to affect anything. Another thing is my lights, they're all 12 volts, so, and also that CCTV transmitter, so what I'm going to have to do is run them all off a single 12 volt battery, but all I could do is just charge it off the 24 volt system using the power lab here, just every now and again as it discharges. Or I might have one of these buck converters connected to it all the time to float charge it. So I'll just get all these disconnected just now and connect them all up in parallel, and maybe give them an equalisation of mains electricity for a little while, because we're at 12 volt just now and there's not much sun coming in, so unfortunately this means the electricity for this one. Now I don't have any nice copper battery terminals here, so all I did was just make them into a circle shape and put flux and solder on them, and that seems to work quite well. It's 16mm squared wire, which should be fine for a 24 volt system. So rather than an inverter, which I don't have yet, drawing about 300 amps, I'll be drawing about 150 amps to run the pressure washer. These ones have automotive terminals on them, unfortunately. That spanner's wrong size. Let's see. They all seem to be the wrong size actually. Anyway, I'll have to get these all off and connected up in parallel. They'll probably have to be charged at 40 amps at 6 volts, because 6 volt charging is pretty inefficient. Another thing I'll mention is this green wire here. It's actually a ground wire which goes to an earth rod outside. I had to add this because the inverter, the grid tie one, sometimes would interfere with the CCTV and cause a loud buzzing, so I just put the ground on and that seems to have sorted it out rather nicely. So I did try and sort of make them into terminals that you could put a bolt through, but the automotive terminals came in the post, so I just decided to use them. Well, that's them finally all in parallel now, and I'm just charging them, so put the current right up to 40 amps. And you can't see very much there, 40 amps. There we go. So to charge at 40 amps I'll be taking roughly 20 amps from my 12 volt battery. Now this voltage is dropping quite fast and we're only getting 4 amps from my panels, so I'll see what this battery can give me, and then once this one runs out I'll switch over to mains power to charge these, because we need to get them equalised, because I have no idea how they're going to perform in a 24 volt system as they're different ages. One pair's older than the other by about maybe 2 months. So we've now enlisted the help of two Xbox 360 power supplies, which together can provide 28 amps continuously. So as this voltage drops here, the watts are going to rise here, because as the voltage of the battery comes down to 12 volts, they will pull more power, and as it drops down below 12 volts they'll pull even more. So this is going to gradually rise, and take up the power that the battery can't supply. And it keeps rising. Both of them are just connected in parallel, directly in parallel with my battery, which is just on these connections here, and it seems to be holding the voltage quite well. We're pulling 25 amps from the supply here, so it would seem that most of the power is actually coming from a battery rather than the mains, which is good. While those were charging, I'd like to talk about my oil cooled grid tie inverter. All that's in there is white mineral oil, and I've got 3 small fans which are immersed in the oil and they circulate it around. And in the end there, there's a heat sink which is connected to a water block which takes the heat out of the oil. Now this means that I can run this thing at 500 watts continuously and it doesn't heat up very much at all, and it cools the transformers in there as well. It cools them very well. Also, another modification I did, if you look at these inverters, this is made by KD. It did have a very small potentiometer surface mount next to where the LED panel is. The connector comes off there, so I just extended it. Now what that does is it lets you adjust the power of the inverter, or rather its maximum power voltage, for working with different solar panels. So if you turn it down to one end and plug in to 24 volts, it will draw only 1 or 2 watts. But then if you were to turn it all the way up, it would probably destroy itself because it would hit over 800 watts. I've had it up to 600, but I wasn't wanting to risk it too long sitting at that high power. But on 12 volts, the maximum this inverter will really give out is about 200 watts. Well, rather at about 14 volts. But at 24 it'll happily run at 500 watts continuously. Even at night when I've got it connected to the batteries, it runs no problem, and I might show that later on. Now this is what I was talking about with charging at 6 volt being very inefficient. The wires are fairly warm. This small section is 12 gauge, it's quite warm. The 8 gauge section isn't very warm at all. This is directly connected to a connector that I moulded into the terminal here. I just soldered it in with a hydrogen torch. That's not warm at all. This negative post, well, the crocodile clip is quite roasting. And these interconnect wires, they're slightly warm in places, not very much at all. It's not too bad. Doesn't need to be there. But they've got a long way to go yet. They're sitting at 7.063 volts, so they'll need a little while. Then after that, I'll equalise them by connecting them up to a buck converter that I've got. 3 of them connected in parallel, which seems to have got broken when it fell. No, that's fine. I'll connect them up to this and equalise them. Well, the point I'm up to now is completely rewiring the solar panels for 24 volts, which is a right pain to do. So I'm going to have to get twice as many connectors. Luckily I've got them all here. And I'm just going to have 4 on this side and 4 on this side, and I'll wire them up for 24 volts. Problem is, these buck converters only take 30 volts maximum input. Now the open circuit voltage of these panels in 24 volts will be over 40 volts. So I was thinking I could get 2 of these and put them in series, and that should hopefully work. That relay is 12 volt, but the relay coil I could somehow run on 12 volts to do the buck converter, so it shouldn't be any problem. These capacitors are half hanging off the wall anyway, so might as well pull them off. They are 50 volts, so kind of pushing it, but it should hopefully be okay. And all those T15s in parallel, their charge current has come down quite a lot, and it should all be bubbling nicely. Or a little bit. Things are beginning to cool down. Well, I've been at this for quite a few hours, but that's the wiring finished. It's all configured for 24 volts now, and it all goes down to here. So with it being 24 volts, we should get less energy lost in the controller and the wiring. And these batteries are now equalising nicely. All of those batteries only drawing 5.84 amps, so they're doing pretty well. Specific gravity should really be 1.28, but I can never get to go. Just give it a wee shake to. I can never really get to go up between or above 1.26. Some of the batteries are higher than others, but no matter how long I equalise them for, they just don't seem to be going up. I'm not sure why that is, but they've been giving me a bit of trouble that way. That's 1.26. It's my older ones that are not rising as much, but this one here, this one's quite a bit higher. This one's at 1.275. But I'm not really sure what's going on there. I've had them equalising for a few hours now, but it doesn't seem to be making much of a difference. So all what's left to do is to disconnect 12 volt battery, because before they were all in parallel, and just those two wires hanging down there will be for the 24 volt system, and the 12 volt battery will be disconnected. And now instead of shooting up to 50 amps in the summer, we only get 25 maximum, but at twice the voltage. So I hope you found that interesting, and thanks for watching.